Okay, I think we're going to get started. Thank you so much for coming to learn more about optimizing your performance of your MarkLogic applications. So what I'm going to do is introduce myself, and then I'm going to turn things over to my colleague here. My name is Erin Miller. I'm the manager of our performance engineering group at MarkLogic in the headquarters engineering group. I've been with MarkLogic almost 10 years. I started off in professional services, building applications for customers, and now I'm on the engineering side of the world. So I've seen sort of both sides of the performance challenges that we have and that our customers sometimes run into. So I'll be talking a bit today about that.
I'm James Clippinger. There we go. I'm James Clippinger, commonly known as Clip. I am the Vice President of Strategic Accounts, and if you think it's sort of weird that a sales guy is here talking to you, the Vice President of Strategic Accounts does a lot of interesting things at MarkLogic. I run our Strategic Accounts engineering team, which works with many of our strategic customers on technical issues they have and sort of interesting projects that are out there. I also run our global performance practice in the field. So whereas Erin has seen both sides of the fence, I only see one side and just complain incessantly about engineering. Engineering's great. There are a number of engineers here. Mary might hurt me.
We love you, Clip.
Anyway, I've been with MarkLogic for a little over 11 years. I've had a number of different roles. I've worked on both pre-sales and post-sales engagements with government customers, commercial customers, people I meet out on the street, whatever it takes. And I'm based out in Tysons, Virginia, but I also travel around quite a bit. And looking around this room, I've seen a number of you visit you at various points in time. And so we're here today to talk about optimizing application performance. And we're going to start off talking about writing scalable queries. We're going to talk about how to plan performance tests and the right way to do performance tests, how you execute those tests, and then how you interpret the results of those tests and really figure out what the tests are telling you, and then how you find and alleviate bottlenecks. And you'll notice that we have a big focus this year, for those who've been at our presentations in previous years, on testing. So this is going to be a recurring theme today, is the importance of testing, how to do testing, and what testing is telling you. And we're going to start off talking about writing scalable queries because that leads into why we think testing is important. But first, because I'm a bit of a narcissist, I'd like to tell you about my new side job. So for those of you who follow me on social media, you'll know I'm quite a hockey fan. I'm a big NHL fan. I go a lot of Washington Capitals games. And because of this, when we were doing videos to promote MarkLogic World, Jim Clark was saying, well, maybe a good warm-up question would be, there's an NHL expansion team that just started in Las Vegas. They're talking about adding a team in Seattle. How would you choose players to be on an expansion team if you were to be choosing players to be on an expansion team? And I said, I can't rank NHL players. They're like my children, they're far too valuable for that. But I was lying to him because I have ClipRank, which is a patent-pending method for determining who the best hockey player is from a particular set of hockey players. And it has a bunch of factors that figure into it. It is, of course, implemented in MarkLogic. And it takes all the universe of factors into it. So the NHL has actually hired me, to be the head of analytics for the new hockey franchise, which they're putting not in Seattle, as you might have heard, is the leading contender, but in Hans Island. And so this is a spec, it's a little far north, but hockey is a game played on ice, so it makes sense that it would be someplace northern. And it is conveniently located between Europe and North America. So you're not expanding the league too far. It's not as crazy as expanding to London or something. And the Danish government is really behind this and has provided some very strategic assets to encourage us to build on Hans Island. So, and they're the customer. They're providing a lot of the funding for this. They do have one interesting request. So the Danish tourism people say, yes, we want you to focus on hockey players from the country that Hans Island is in, but for tourism reasons, we would also like those players to share a first name with the members of Metallica when they recorded Ride the Lightning. Because, as everyone in the room I'm sure knows, the album Ride the Lightning was recorded in Copenhagen. So this is a key push for their tourism efforts to get the world to recognize the importance of Ride the Lightning having been recorded in Copenhagen. So we now have ClipRank with Lightning. I filed a new patent application for this. Suddenly there is a much greater weight on players named James, Lars, Kirk, or Cliff. And Cliff, clip. You know, I'm pretty okay with this. You know, my narcissism is still pretty much sated. And I then run this in my MarkLogic database that knows everything about the world because it's a pretty awesome database and I scaled it out well. But I decided to use SQL because it's the hot new feature, it's really cool, but I don't know it that well because I've been developing a NoSQL database for the last 11 years. So my SQL is terrible. It's really, really bad. If you read through this, it's finding players based on the geography of being in the same nation, from the same nation as the nation that Hans Island is in, and then ranking them using clip rank TM with lightning TM. But then to find the highest scoring player, it finds the maximum scoring player in the entire universe of those in the same country as Hans Island, and then takes that maximum value and matches it up. So this is terrible SQL, but it's still pretty quick when I run it. So I ran it last month, and it came back with Lars Eller, who's Danish hockey player, first name Lars. He meets all the criteria. Fantastic, this is great. I know exactly who to target for my team. But I ran it a few minutes ago, and it came back with James Neal as the result. And James Neal is not Danish, he's Canadian. So this is very perplexing. And it took a really long time to run, way longer than the last time it ran. So does anyone know what happened in the intervening month? Canada invaded Hans Island. So suddenly, hockey players from the country Hans Island was in went from the 7 current NHL players from Denmark to the 441 current NHL players from Canada. And suddenly my Cartesian product query that was really not that efficient against 7, but 7 times 7, yeah, 441 times 441 is really not good. And if you say, geez, this is a lot of artistic license you're taking here, Clip, this actually happens. Hans Island is split between the two countries, and both sides, in a very noble way, land on the island, leave liquor for the other country to discover, and then go away and then come back. So it really does flip between the two countries. They're working on it. It turns out, given the location, it's not a huge priority for them to solve this problem. But it's one new piece of data that comes in, a relatively inconsequential one to the rest of the world, and it totally changed the performance characteristics of my query, in addition to changing the results that I got back from that query. So this is what writing scalable queries is all about in MarkLogic now. So now that we have SQL, now that we have Sparkle, now that we have joins occurring, traditionally, and I mean, when we've talked about this in past years, we've said, you can do a lot of estimation and guesses and thought about how your queries are going to scale because they're search queries, and we understand how search queries work. But as soon as you bring joins into the mix, you need to think and test a lot more how your queries are working, because it's no longer just the queries that matter, it's the interaction of the queries and the data that matters. So it's important to think about how to use the indexes as much as possible. That hasn't really changed. You still need to think about how to use the indexes. You need to think about how to minimize the number of fragments fetched. And then you need to align your indexes and your documents to your use case. So these are all universal things that apply to all queries in MarkLogic. And these are the things we've been saying for a while. But with SQL and Sparkle, as I say, a small change can lead to a huge change in resource consumption. One new fact could come in, and it could just totally change what your query is doing. And that's rough. That's really difficult to figure out your resource picture without testing. Remember I said testing is going to be a big theme. Testing is a big theme because that's how you figure out and ensure that your SQL and Sparkle queries will meet your SLAs. Then there's also cost-based optimization in MarkLogic for these queries. So keep in mind that you may give it the query the same exact inputs, but you're going to get different performance characteristics because the costs have changed, because your data is changing underneath it. So even if your results aren't changing, your performance may change run to run because of changes to the data. And then the optimizer itself in new releases of MarkLogic is continuously optimized by our engineering team to get faster and better at various use cases. So something that was slow last week when you're running on 904, it might be fast this week on 905. And that also leads to one of our top optimization hints, which is upgrade. Upgrade, upgrade, upgrade if you're seeing performance issues with SQL or Sparkle. Because you may, and this is a very common thing with the customers I work with, you run your query, you run it under 902, you find it slow. I run it under 905 and I find it's fast, and then you're good to go. That's one of the, It's not a zero cost operation, but it's generally lower cost than trying to optimize your way out of the problem manually. So how do you then deal with SQL and Sparkle queries? And these are our recommendations. Our recommendations are to think really holistically about your queries, your data, and how they will interact. Then build a prototype, try things out, make sure they're operating the way you expect them to, and work in that prototyping environment to understand what the queries are doing. But then, before you go to production, if it's a performance critical system, you have to test at full scale. So full scale of data, full scale of queries. You can't sort of estimate your way around this when you're dealing with SQL and Sparkle. You really need to just go and test it out. And Aaron will be talking more about all of these topics as well. So how do we think holistically? So think about how the query will work with the indexes. And this is bread and butter work for those of us who've been working with MarkLogic for a while in terms of thinking about how the indexes get used. But the new thing is really thinking about how the query will interact with the data. So think about how if the data changes in predictable ways, it will change what your query does. Think about how if there's dots connecting in your data, so the thing about Hans Island going from a country that doesn't have many hockey players to a country that does have a lot of hockey players, that is something that you probably aren't going to foresee, but you should think about how you can limit it in your query and how you can engineer your query to keep those limits in mind. And then, as often happens, the best optimizations often involve remodeling your data. So reharmonizing it if you're using Data Hub Framework, rerunning some corp jobs, doing whatever it takes to get the data in a format that best fits your use cases and aligns with your resource consumption. And then part of thinking holistically too is, what is the risk if you're wrong? So I work with a number of customers who say, I want the fastest possible SQL or Sparkle query. So optimize this one query until it's perfect, please. And we can do that, right? We can do that. Once again, though, with cost-based optimization, it's going to be a moving target. And particularly as you upgrade to different versions of the optimizer, it's going to be a moving target. But usually, these are queries where it's important for it to be a certain level of fast. It's important to meet a certain SLA. It's not a query that really should be getting hyper-focus. It's just getting hyper-focus because it's a particular performance issue today. So think about what are the risks if the query is slow. Think through what are the risks if the data changes under the query, and really assess that holistically as well. Then prototyping. So try your query against your best available test data. So the dream is every developer has their own full-scale copy of the production database ready to go, unredacted or redacted. I mean, redacted's fine too, and can test everything for performance at full scale in production. That doesn't going to happen a whole lot. I mean, right, that's our dream as developers, and particularly as performance-focused developers, but that's not real feasible. It's better to have a representative portion of the production data, also perhaps redacted, but the thing we tend to discourage is generated sample data. We've had enough customers, enough projects, and enough projects that we ourselves have worked on where there's generated test data. The generated test data has some trends in it that don't match trends in production data, or that sometimes are too optimal, which isn't a phrase in English, but it's still sort of something that is in some way hitting a sweet spot for the server that doesn't exist in the production data. And so it's dangerous to generate your own test data. Sometimes it's the best option you've got, but for performance purposes, it tends not to work well. Said it before, I'll say it again, upgrade. Keep your prototyping environment upgrade to the latest version so you're not chasing performance issues that have already been fixed by our engineers. Because even if it turns out it's an upgrade that'll take you some time and some energy to deploy in your production environment, at least at that point you know that the upgrade will fix it. So that's an important data point to use. Then use our standard query tracing techniques, which if you're not familiar with them, I recommend our previous MLW presentations, some of the white papers we have out there, some of the knowledge base articles out there, to see what your query is doing. So here we have a query. I think I have a laser pointer here. Sorry, folks on that side of the room, but yeah. So we see the expanded tree cache hits and misses here. And notice that our expanded tree cache misses are not too bad, right? My audio? Okay, good. Okay, good. The expanded tree cache misses, 441, not so bad. But we have a lot of expanded tree cache hits. And usually, cache hits, we say, well, that's pretty good. My cache is doing work. It's a good thing. But this, in this case, is pointing to a Cartesian of two large data sets, or two moderate, 441 is not a huge amount of data, but it's pointing to it happening, and this is, in query meters, a very quick hint that something is wrong. If you see very large numbers, even for something like cache hits, where you would normally say, well, if it's better than cache misses, so yeah, that's pretty good. Keep in mind that's there. And then test at full scale. So for actual, if you have production SLAs, and if you're using SQL and Sparkle, please, please, please test your applications first. Test them in a non-production environment or your production environment before it goes online at full scale with production hardware, with a full replication of the data and a full replication of production traffic. And this is really about application level testing. So this is testing everything in the stack, not just MarkLogic, and making sure it performs. Which, if you have SLAs for a production environment, this is kind of how you should roll anyway, right? This is the sort of performance testing that we as an industry tend to expect. But we're really focusing on now, whereas before we might have been able to say, well, with search applications, now it's no. Once we bring joins and inferencing into the picture, we really need testing to happen. If you're running in the cloud, there are fewer excuses for not doing full-scale testing, because you can roll out a cluster and roll out the rest of your stack pretty quickly, test it for a day or two, and then roll it right back down, right? So that's sort of a mind shift, I think, for all of us still. And I'm looking around the room, I see customers who I know are cloud is second nature to them, and they're like, oh yeah. What are you wasting time telling us this, Clip? But there's other customers who it's still, you need to sort of be reminded that yes, the cloud is out there, and the cloud is available in very small increments to be able to run large systems for short periods of time. And it's a very handy way to test. And then if you can't do testing at full scale, once again, assess your risk. If your company is going to be obliterated if the system doesn't meet its SLAs, which we have financial services customers where that's the case, then yeah, you probably better do full scale testing. If your boss is going to be mildly annoyed at you and might call you on the weekend, well, maybe that's not so bad. Depends on your boss though, so I'm not commenting on that. As noted, assess your risk. So to sum up, writing scalable queries has gotten more complex with SQL and Sparkle. It still required a lot of thought and analysis with standard search queries, but now with these new tools that are out there, you're really talking about a new world, not in a good Disney sense, but in the sort of unpleasant. Yeah, it's just rough, and testing is our best approach. So write your scalable queries, think through the data requirements from day one, and think about how your data is going to support scalable queries, and then testing provides the best insights into performance characteristics. And so how do I run these performance tests? I'm not sure. Aaron, do you know how?
I don't know.
Okay, well, good luck with that.
All right, thank you. Thank you, Clip. All right, yes, so changing gears a little bit to talk about how to actually run these performance tests. And Clip, thank you for your sports ball portion of the talk. I'm going to switch to a fine art metaphor and say, why do we want to run performance tests? And I have certainly felt like this person. I think if you're in this room, you either have felt like this person or don't want to feel like this person, which is you're trying to go live, you're trying to deploy your application, and you get to the 11th hour and it doesn't scale, it doesn't work, you're in a war room, you're in a conference room for days on end, somebody's saying, why doesn't it work, figure it out. It would be great to avoid that experience if you haven't had it. So that's what I'm going to talk about today. And we're just going to talk about the life cycle of a MarkLogic performance test. And it's very similar to any other application performance test that you would do. But I've kind of broken it out into these there are stages, but there's a lot of overlap. And so some of this stuff, especially in the beginning, might be happening concurrently. So obviously, as Clip said, from day one, think about your data, think about your queries, write scalable queries rather than having to, if you can, rather than having to go back and try to figure it out months later when maybe you don't even remember what code you wrote, it's always nicer to kind of approach that up front. So also, in terms of defining goals, often application developers are in a situation where you've been handed an SLA by the business. We need to do it in this, this time frame with this many concurrent users. So often that's been defined up front. If it's for whatever reason not defined, it's still interesting to sort of, maybe this is a new application, maybe people don't really know yet how it's going to be used. You can use your performance test to do capacity planning and figure out what's a reasonable area for your SLAs given your hardware. And then we're going to talk about how best to plan your performance tests and then how to understand the results. So this is a diagram that's from a white paper called Understanding System Resources. So there's a lot going on here, and I'm not going to do a deep dive into this particular diagram. But what I was trying to do here, in publishing this, was to show you there's a lot of different components. This whole box is just that MarkLogic executable. But here's the different components inside and the different sorts of system resources they might use. So for the forest, on the data side, you're using memory for the caches, CPU to create the indexes. So it just gets you thinking about when you're writing these queries, you're using system resources, it's all going to come back to as we try to determine where bottlenecks are, what resources are in play. So let's talk about planning your test. And like Clip said, make sure you grab the latest version. And I'll also add to that from the engineering side of the house that our engineers are constantly optimizing for performance. There are good reasons to grab the latest if you can. So you want your performance test environment to look like production as much as possible, as for the reasons that Clip talked about. So I'm not going to go too far into that again. But that can be configuration data, obviously application, query load, and we'll talk more about query load in a moment. Isolating your environment. I've certainly been in the situation quite often where I'm with a team, we're running a performance test, everybody's sitting in a room looking at the results, and it's like, that's weird. Why is there so much CPU being utilized? I don't understand. We wrote this code, we rewrote it last week, start drilling into the metrics, and it's like, why is that app server in use? And eventually it turns out that perhaps another team was aware that you had this performance cluster, and they're just doing a couple of things over here while you happen to be running your test. So important to make sure before you run the test, you've locked down the environment and the traffic is for the test. And choosing your benchmark tools. Again, you may have a performance or capacity team that just says, we use LoadRunner, we use JMeter. If you don't have a tool, at the very least, make sure you choose a tool that at the bare minimum will report throughput and response time. Okay, testing your workload, choosing representative queries. So what's the best way to come up with a set of queries for your performance test? Pulling your queries out of basically replaying your production traffic is great, because then you've got, okay, this is how people actually used it for a day. So I know that this is how users interact with the application. You can grab that from, if you're already in production with MarkLogic, you can grab it from your access logs, your error logs if you're logging queries. Otherwise, you might grab it from your app server logs in the middle tier, or there's any sorts of logging depending on your config. You might not be able to do that though. So there's some things you can do. You can instrument your code with XDMP query meters. So that's I would actually add that as a debug option. You can do XDMP log and then choose debug so that you can turn it off and on with the configuration rather than it's always on and, oh, look, I created a bottleneck by writing out to my MarkLogic log. That's not a good, when you create a bottleneck with your test not a great situation. So make sure you're judicious about doing the instrumentation. In terms of, the workload, you want to make sure you've got the right ratios. So let's say I have an application. First thing it does is look up a customer, and then it does a bunch of other stuff. Look at the customer's address, see what other products the customer's bought. You don't want your test to just be the look up the customer part. You want to exercise the whole set of APIs, and probably as best you can in the ratios that you're going to be using in production. And finally, there's the sensitivity parameters, where you as a developer, you have a sense. It's like, I'm really worried about what happens when we run that batch reporting job. What's going to happen to my queries? Figure out, you sort of have an intuition about the weak points. And I think as much as possible, pushing on those weak points are a great thing to do in your test environment rather than your production environment. So now we'll talk about how to execute the test and understand the results. So I'm going to talk about this methodology that we rely on quite a bit in performance engineering. It's called the use methodology. It's pretty simple, actually, which is what I love about it. It was developed by Brendan Gregg. He's a Netflix performance engineer, and he wrote this book called Systems Performance, which we are reading all the time and quote to each other periodically. It's a great book, so definitely check it out if you're interested in this. So his methodology for understanding performance is to say, for every resource, check the utilization, saturation, and errors. So what does that mean? So we'll talk in a moment about what a resource is in our world, but in his world, it's and ours too, it's all physical server components, CPUs, disks, because he's a large scale Netflix, a couple people use that. So he's getting into switches, he's getting into internals of cloud networking that he's got to think about all the time. So utilization is the average time that the resource was busy doing work. Saturation is basically a queue, like you've hit a threshold and now the resource has extra work that it can't do yet and it's queued up ready for it to do. And obviously errors is your error events. So resources in MarkLogic, we also have those physical resources. We tend to think about it in these 5 categories: CPU, RAM, disk I/O, and that's I/O throughput, storage capacity, and network. And generally, it's the first 3 that come into play most often with performance issues. Sometimes 4 and 5 do, but really it's the big 3. There's also MarkLogic resources to keep track of as well, not just the physical resources. So you've got caches, disk writes in terms of both merges and journal writes. How much memory is a forest using? What's that look like? Keeping track of your huge page usage. And hopefully you've got transparent huge pages turned off. And if you don't, there's a knowledge base on the support website. Go check that out. Probably right after this. But you can also get visibility into how many huge pages you're using and if you're making best use of them. Same with registered queries. You can get stats about database replication, document locking. And dnode round trips is kind of, I'll talk about that in a moment. But basically, that's the time that it takes for a request for the query to be resolved on the dnode and the response to come back to the enode. And sometimes that information can help you understand either a network problem or a slow dnode. So we'll talk about that too. Response time graphs. So generally what you want is that linear. It's predictable. As you add capacity, you are able to continue to scale. More commonly, I actually very commonly hit the ceiling, which is you just run right up against the limit. That's it. You can't go higher than that. And the knee is a similar profile, but it's in the sense of something has happened at that bending point, so the scalability profile has changed. And so then it's up to you to figure out what that is. So again, that's why we care about this diagram, right? So now I'm going to show you, this is the demo portion. It's not, I don't know if I would call it a demo exactly. It's more like, it's a little bit hard to demo a performance test. It's like, okay, now everybody go get a cup of coffee for an hour. So we're not going to do that. But what I am going to do is just show you, I'll show you some code and some tests that I ran and what I did and how I figured out the metrics and what was going on here. So this is my test. This is pretty simple. This is xQuery. All this code is doing is returning a search. It's always bounded, so see where it says start and page length. It's always 10 results. The query is just a term or set of terms coming in as a URL parameter, which is coming in up here. So it's just getting the request field. And the query itself is just a word query on the term or set of terms. And as well, I'm just generating some facets. This one, username, IP, a timestamp bucket, and then finally an ID facet. And so, not very complex, very isolated kind of query. So what I'm testing with this is how much load can I throw at my server, and that's what I want to find out. So I've got my response time throughput. I run my test. I want to find out the baseline. If I can push the CPU as hard as I can, which is what this test is designed to do. So I've run my test. Okay, here's my final output. I get pretty good throughput on my single host. I got 254 queries, requests per second, and an average response time of 377 milliseconds. Okay, great. So there's my baseline. So now somebody asked me to add something. I have a business saying, hey, can you add this feature to the test? I'd really like to know what the most popular search results are. So can you keep track of that somewhere so that I know what's going on? No, sure, no problem. That's really easy. So I'm going to go back to my code here, and I hope, there we go. And I've just added one line of code. It's super easy to keep track of. What I'm going to do, I'm just going to log the first URI that I get back with every search result. I'm just going to log it in this document called latest XML, just stick it in the database, and then I'm going to have everything, and then I can kind of post-process it later and say, what was the best, what were the most common URLs. So cool, here I go. I'm going to do this, and I'm going to run my test again. Uh-oh. My throughput is down to 36 requests per second, and it's taking more than 2.5 seconds to run. What have I done? All right, so at this point, what I'm going to do is move over to my query console. And I'm sorry, my monitoring dashboard. So monitoring history, meters, we've got a meters database where you can capture all this information about everything that's going on with the server, and it's critical for performance tests. You definitely want this feature on, and you want to be logging this data when you're running performance tests. So I'm going off over here to my monitoring dashboard. It's running on 8002. And here's the first test, the baseline, where everything looked pretty good. And then, here's the second test. So I'm going to start, okay, that's right, use. Let's go back and figure out for each resource what happened. So I start looking at this. Here we go. Here's the first test. Things look pretty low. The disk throughput doesn't look like it's being taxed. And then, on the second test, we're doing a lot of disk activity, a lot of merges. I bet this is because I was ingesting content. It's the ingestion team. It's their fault. That's the problem. No, don't do that. Keep going through your data. Remember, it says for every resource. So while, yes, we were ingesting data, let's see what else we can learn from this monitoring data. So again, here's the comparison. Here's test 1. And then you can see right here is test 2, where all of a sudden we go from I'm up at 84% user CPU, and down here all of a sudden I'm at 45. And all of a sudden also I've got the system CPU that's coming up. Why am I using system CPU? That doesn't make any sense. Okay, so I'm going to continue on down my path here. There's something really weird going on with memory on that second test too. Look at that. So on you go, and it's observation, right? You're looking at your test results. You're trying to understand for these resources what happened. And then we come to the locking portion And, oh, look at that lock rate. Does that say 200,000 locks per second? That's not what I meant. Why is that happening? I'm just updating one document. No, you're not updating one document. When we, going back to our code here, so MarkLogic does some static analysis. And we'll look at this and see, okay, XDMP node insert child, that's an update transaction. Every document that gets referenced in the context of this transaction module is now going to be locked for update. That includes all these search results that are coming back. So you've now unintentionally put a write lock on all of your search results. In addition, you've created a bottleneck on latest XML, right? Who needs it? You don't need latest XML. You can update the metadata in the document itself. You don't need to, by writing the code this way, you've essentially guaranteed that everybody has to wait for latest XML to update, which is not what you want. One other thing I'll add here is, I noticed all those locks. Maybe I should look at the error log. And sure enough, when we look at the error log, you can see that there's a deadlock detected. And again, these deadlocks they're documents that I'm inserting into the database, but everything's being locked because of the way that code was written, with the search, all of the search results being locked for update. So that just kind of gives you a flavor of how to use the monitoring data. And obviously this is like a high-level overview and it's very fast, so it's not, I'm not going into each individual resource, but I will say to be sure that you do check all of them, because you can sort of be misled, like I was initially with the dis usage. You can kind of think that it's one thing and then realize, oh, I really actually messed this code up. It wasn't the ingest team at all. Oops. All right, so finally, finding and alleviating bottlenecks. And again, this is a really big topic, and I'm just going to do kind of a very brief overview here, but a couple of things to think about. The most important thing is probably your use of caches. Whenever you have to read something from disk, it's going to be much, much slower than if it's already in memory. So you really want to keep track of your cache hits and misses. And you want, particularly for the list cache, if you're doing any sort of search, even if you're like, I'm not writing a search application, you might not be writing a traditional search application, but you're probably searching for documents somewhere in your app, and so therefore the list cache is going to be critical. And you want that in the mid to high 90s, that ratio. You want to make sure that you're not loading the list cache from disk every time you run a search. And if you see really low numbers there, then there's a problem. There's a major issue with how you've set your indexing up, or perhaps the size of the cache, or available memory. One other thing I'll add, because we've been talking a bit about SQL and semantics, is if you're using SQL and semantics, you want to be sure that you've tuned the triple cache and the triple value cache. Generally speaking, these things out of the box work pretty well. The triple cache holds references to the triples, and I believe the doc IDs that they came from. The values actually has the value of those triples. So you want the values cache to be bigger than the triples cache, which might not be intuitive at first. So it should be about 2x. Also, using query meters, as Clip was showing us earlier, checking to make sure that the number of documents being returned is what you expected. Checking your round trip times as well to make sure that there's not a slow node, locks, and cache hits and misses. Going back to our use methodology, when is saturation a problem? The only time it's a problem is when you're not meeting your SLAs. It doesn't matter if your CPU is maxed out, if you're fine, you're within your SLAs. It just gives you information that, okay, this is the capacity of this system. This is how far I can go. So finding your knee or your ceiling is important, as well as using use to find the right resources to tune. And don't forget those error logs. So the basic summary is tune your queries or add resources. You might need to add memory. You might need to add another host. You you might need to do both these things. And again, this is a very general takeaway. We're going to be diving into this in much more depth in a workshop tomorrow, which I'll talk about in a moment. So getting back to our scalable query takeaways, got to think about data and queries on day one, especially if you're using SQL and Sparkle, and make sure that you're testing properly. And when we think about testing, you want to plan a good test, make sure you've got data that matches representative queries, representative workload. Use the use methodology to understand, use the monitoring dashboard to understand what's happening, and understand your scalability profile and graph. And finally, here's some additional resources. Clip and I will be teaching an MLU workshop tomorrow. I believe it's sold out, but if you're interested, get onto the waiting list, because people always, you could listen to us for hours as well. So that, I mean, what could be better? So that's going to be that's going to be tomorrow. As well, MLU runs this course frequently. So please, it's a great course, and it's a really good opportunity to learn more in much more depth about these topics. We've also got some white papers here inside MarkLogic. Will be everything you ever wanted to know about MarkLogic. Understanding system resources is a great white paper as well. I hear the person that wrote it worked really hard on it. That was me. And I'll have a performance testing white paper, which we'll be publishing soon, also on the developer website. And finally, there's the website for our friend Brendan Gregg, and definitely check out his book. So with that, I will turn things over to questions. Stunned.
Yeah,
the room is stunned.
We do need to wait for microphones to get to people because we are recording.
Hey, just wanted to understand. So what we saw and what we spoke about was mostly retrieving the data out of MarkLogic, like how optimized my query could be to get the data out of MarkLogic. But what I was trying to understand is, let's say I have an MLCP command to load thousands of files into MarkLogic, and there I'm hitting a bottleneck. How do I go about to understand, is it optimized, or can I do something on infrastructure side to have more clusters or something?
Yeah, so in ingest optimization, I don't want to say it's easier, but it's easier because there's fewer variables, right? You're really just stuffing the data in as quickly as possible. And the things that we tend to look for there do you have a true hardware bottleneck? So are you running out of CPU? Are you running out of disk bandwidth? Or very rarely running out of memory? Or is it that you need to throw more resources at pushing the data in, which is often the case where you need to increase your threads on MLCP or the app server, or both?
The other thing I'll say about that is sometimes, you can certainly do a transformation on ingest with MLCP, and that may involve some queries. So if you're doing any kind of transform, you might need to optimize that. And think about that as almost like a query portion of your test.
Yeah.
Thank you.
And the same is true if you're harmonizing with Data Hub Framework. Those are still queries. They're not magical unicorns that transform your data. So, yeah.
They're not?
Magical unicorns aren't until 907.
Oh,
yeah,
okay.
Yeah, shh.
Oh, don't tell anyone.
So what is your approach for testing against different hardware architectures? Like, for example, you touched on caches. Those, the impact of, hitting the hard drive, for example, is completely different if you're working with SSDs or stuff like that. So what is your approach for that?
Yeah, I think that's a good question. SSDs are going to be a lot faster. They're still not as fast as memory, right? So, but you're right. You do want to, if you have different hardware options when you're you might even be trying to decide what to procure, right? Like what should you deploy on? That's a great opportunity to run a test to try to figure out comparing different configurations. I would say what you want to do there is really focus on, let's say you start with hard drives, right? Let's say you start with, I don't know, a RAID configuration or shared storage or some configuration that you've got that usually works pretty well. You should make your next decision about what should be the next hardware configuration you test. You should take as input what the bottleneck was with that first test. So if you run a test and you find that you've got a big disk IOPS bottleneck, well, definitely going to SSD is going to help you. So, but if it's not a disk IOPS bottleneck and you're running out of memory, SSD isn't going to do much for you, right?
Yeah,
So,
and the one thing I would add based on customer experience is tools like FIO can be very useful for
Right.
things like determining what your disk bandwidth is, so you know whether MarkLogic is hitting the limit or if it's just that you're not pushing the system hard enough.
yeah, that's an excellent point for disk in particular.
Yeah.
I don't know if that gets at the answer to your question. Does that help?
I mean,
Okay.
it's mainly when you're optimizing, right?
Yeah.
What do you optimize against, and how do you make sure that the optimizations that you're applying are going to work well against different
The hardware that you're,
architectures?
which is why it's good to be testing against the hardware that you're going to be using, right? You're exactly right, because you could be in a test environment where you chase a bottleneck that doesn't exist on a different hardware profile. So it's definitely a challenge. I mean, that's a case where if you know you're going with a different hardware profile, but you can't, for whatever reason, get a full-size environment, validate all of your testing with a scaled-down environment. That's, it's not ideal, but it's definitely the hardware can make a big difference.
Yeah.
So it's important.
Hey guys.
Seriously?
Actually, no, it's just a question that occurred to me. I'm on her team, by the way.
Yeah.
Mark and I.
Today you're on her
right.
team.
I'm going to
That's
ask Clip a question, though.
Okay, good.
I know that you said that that the times when you've encountered, or several times you've encountered, where customers are generating sample data to test.
Yeah.
Are there any techniques, or is there value to be found in being able to generate data from representative data at scale and using that as opposed to full scale?
So you're talking about redacting, or?
I mean, like being able to take some smaller sample of representative data and creating a generator that uses that as a seed to create more realistic data at scale. Has anybody done that, or
They've tried, and they usually because that's. I worked with a customer very early in my time with MarkLogic who took representative sample data and just created like 300 copies of it, which is not really a generator approach, but which they would have described that way. And guess what? That data compresses really well.
Yeah, right.
I mean, we compress document by document, so it doesn't really compress that much. But in terms of what you see in your range indexes, because of the way range indexes work, particularly string range indexes, not strange indexes, well, they are kind of strange. But they compress it down quickly. And that to me is the key problem with generating sample data is you need to know your data set so well that it's almost certainly going to be easier to actually get the data. Because between the two of us, we've done this more than anyone, I think. And I don't feel confident writing representative sample data.
Yeah, I'm always very happy to have actual data.
Yeah.
I mean, yes.
Yeah.
I would agree.
Yeah.
Hi. One of the things we do to tackle performance issue is like in relational world, we denormalize. Our MarkLogic world, we probably pre-aggregate our data marts and pre-aggregate the data, right? So where does that fall into, especially real-time REST API calls, where does that fall in the whole performance tuning cycle, like infrastructure, caches, stuff like that? Where does the pre-aggregation fall into?
Yeah. I think a lot of it fits into the prototype phase where you want to be able to see what you can write. I mean,
Definitely. But I also think, some of that might happen in the benefit of something like a data hub is that you can add harmonization flows
True.
as you go. And
True.
so that ends up being an ongoing prototype. And the key is really just to get a good pattern, right? And that's what the data hub gives you, is this envelope pattern where you don't have to worry about all this stuff. We're going to get it into a format that we know will query well.
Yeah.
And so that's probably the best,
But the flip side of that's probably resourcing your system so you can reharmonize and not making it something where it's like, oh, it's going to be 12 years for us to reharmonize all of our data.
right.
Yeah.
True.
Yeah.
Okay.
So what's your recommendation on using SQL and tools like Tableau?
Yeah.
Right? How do you tune that?
Yep. So Tableau and other BI tools can do really amazing things. The visualizations that you end up with can be phenomenal. I think the challenge can be when you want to query when you're using Tableau to query MarkLogic, it's going to do a select star, right? To get all of the data out of MarkLogic into Tableau, and all of a sudden you're like, okay, I'm going to go have dinner now. It's like, so we've made a lot of optimizations. This is another case where I'm going to say, get the latest.
Yeah.
Because we've made huge changes with it. We've worked really hard on this Tableau problem and other BI tool integrations. The best thing you can do is get the latest version, and we're continuing to try to make it better. But I mean, basically, there's multiple ways you can do it. You can do it with the live connection. You can extract. You can use a Tableau data extract, like basically a Java tool that you can use in between to do what you need to do. There's lots of different possibilities there. But I would say get the latest. If you have trouble, call support, because everybody is, they might have some optimization tricks for you.
Right, and they're continually optimizing based on customer feedback, and that's, I mean, I think a more general point is if anyone left MarkLogic World last year and was like, yeah, I'm going to go try SQL, and you weren't happy with the performance, please try it again now, because there have been huge performance improvements between 901 and 905, just massive.
It's true.
So yeah.
I also just want to say, I think we're wrapping up, but definitely the next thing that's happening is going to be lightning talks, which are amazing. They're downstairs,
that's right.
and
I pointed up. I was thinking down.
Followed by a talk with. I'm trying to finish a sentence.
Yeah.
Followed by a talk with Chris Lindblad, who is our founder, and he's always really interesting to hear from. And I also want to say that I put our email addresses up here. Feel free to, I don't know about Clip, but feel free to ask me questions anytime. I'm always happy to hear what our customers are doing and what problems you're running into. So thank you. With that, we'll close it out.
Thank you all.
Thanks.